you have here the curve with equation x squared minus 3xy minus 4 equals to 0. We have to show that the curve and the line with equation 3x plus y plus k equals to 0, it meet for all values of constant k. It means that, okay, if this is your curve, and this is the line, for all values of k, it must be between this line, right? It must be within this range. So let's see. Now remember that within this range means that your b squared minus 4ac, it must always be more than 0. Okay, that is more than what equals to, because equals to means it's just at the tip here. You only touch at one point. Alright, now in order for you to compare with b squared minus 4ac, you have to ensure your equations are equated together. You have your x squared minus 3xy minus 40 equals to 0. The second equation is 3x plus y plus k equals to 0. Therefore, your y is simply negative 3x minus k. If you substitute the y into this equation, then you will be having x squared minus 3x times negative 3x minus k minus 40 equals to 0. Okay, then expanding this, you should have x squared plus 9x squared plus 3kx minus 40 is equals to 0. Simplifying, then you'll be having 10x squared plus 3kx minus 40 equals to 0. From here, pick up your a, b, and c's. I would always like to write it on separate notes so I see exactly what is my a, b, and c. So my a is 10, my b is 3k, my c is negative 40. You have to remember that at this point when you write out your a, b, and c's, you should not be having any x. And none of the x should be there, okay, because we are only pulling out the coefficients. Once you get that, putting it into b squared minus 4ac, then you will be having 3k squared minus 4 times 10 times negative 40. Finding the value of this, you should be having 9k squared plus 1600. Now at this point, you should have make a conclusion that for whatever the value of k, even if k is negative when you square it, you will be having a positive answer. For whatever value of k, your b squared minus 4ac will always be bigger than 0. Okay, so then you can make a conclusion that for all value of k, for any value of k, the line will always meet the curve. Okay, therefore, line will always meet the curve.